Okay, we're continuing with this section so we can finish it off. So I'm focusing right here on question 9 and 10. Number 9, it says, find the equation of a circle centered at 5, -1 with a radius of 4. Well, heck, I think you could redo that. You could draw that out because remember, they want it in this format, blah, 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 plus something here, blah, 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 equals r squared type thing. And then this is x, and it's either plus or minus some value, y plus or minus some value. So you could fill in the blanks on that. But what about something like this? When they give it to me in this format, I can't clearly tell you what the center and radius is until I convert it. But they are giving you a hint. They're saying find the center and radius of this circle. Before I do my 2 examples about circles, let's look at this. Because what we're going to do is we're going to use a completing the square concept. But we talked about completing the square with parabolas. Remember, a parabola, you can take these 2 guys right here, you cut the 6 in half, and you square it, write it as quantity squared. Then you say to yourself, 3 squared is 9. You take that 9 away from the 2, and then this part right here gives you a -7, and you have then converted it into vertex form, and you could easily then tell me the vertex is at -3, -7, etc. And you know it's a parabola because the y equals format. It's not y squared equals format. But we have done this. This we have done. And to do it, we use this trick, completing the square. Because we wanted it to look like this. We want the finished product to look like y equals a times x minus h quantity squared plus k. This is vertex form for a parabola. Well, when it comes to circles, this is what we want the final thing to look like. When we want to rewrite a circle, we want the finished product to look like this. This is the format for a circle. So we use the same completing the square technique, but we do it in a slightly different way. See, when we use it for a parabola, we end up with y by itself and all the other information on the other side. Well, we're not doing that now. We want x squared information plus y squared information equals some numeric piece on the other side that we're going to call r squared. So, this is similar to the question that's on your AP Calc handout here. So let's do it. First things first, I want to pair up the x information. So I'm going to rewrite this slightly and say, let's put this stuff together. And similarly, I'm going to put the y information together. So I'm going to say plus y squared plus 4y. And then I'm going to subtract the 1, and I'm going to move it to the other side. And the reason why I'm doing that is, remember, I'm trying to get it so there's x stuff squared plus y stuff squared equals some number I don't know over here. So here's how we do this. Pair it up. You do it just like you would with starting off the problem for a parabola. And you pair up the information, you cut it in half. So I'm going to get x minus 1 squared. But here's where circles and parabolas are different. If I were to take -1 squared, I'm not going to subtract it from this because remember, I want all the numerical values over here. So I am going to now, instead of subtracting from that side, I'm going to just add it to the other side. Now let's play with the y squared information. So we're going to do y squared information. We have y, somebody is starting their car next to me, plus half of 4 is 2. We're going to have that thing squared. So 2 squared is 4, but I'm not making it a parabola. I'm not taking away the 4 here. What I'm going to do to balance things out is I'm going to add that 4 to the other side. So what happens is, well, this part right here, x minus 1 squared, what you see is what you get. This part right here, y plus 2 squared, what you see is what you get. Don't forget, it's a plus. And then grand total over here, negative 1 plus 1 more plus 4 more gives me a grand total of 4. So what did I do? I rewrote this original polynomial. So it looks like HK form. Look, this is what I'm shooting for. HK form. Now, just like the question they gave us in the packet, it says, find the center, radius, and circle. Huh? Well, I didn't do their problem. I didn't do your homework, but I did show you how to do it. So what's the answer? If I wanted to know the center now, I could say the center is at 1, negative 2. And if I wanted to know the radius, I could tell you the radius is 2 units. Remember, we don't say plus or minus 2. We just say positive 2. Let's play again. Let's do it one more time. Here's my second one. So we go like this. X information, put it together. Y information, put it together. Equals whatever's on the other side, leave it there. Now, I'm going to mess with this first. So I'm going to pair it up, cut it in half, write it as a quantity squared, and I'm going to say negative 2 squared is 4. That is what I will add over here. Plus, here's my y information. I'm going to cut it in half, write it quantity squared. 5 squared is 25. I'm going to add it over here. So I'd end up with negative 13 plus 4 more plus 25 grand total, and that gives me, what, 16. So if they said, what is the center of this circle and what is its radius, now I could tell them the center is at 2, negative 5, and the radius is 4. And that is how you do it. Now, I do want you to know that the questions on this AP Calc thing, this summer packet, they're just, little random facts that you should be able to pull off. I did want to make up just one more extra practice because sometimes we don't get a perfect square radius. That's okay. It can happen. We would still start by pair up the X information. Hey, thank you very much. It's already paired up. Pair up the Y information. Oh, thank you very much. It's already paired up. But what I would do is I would move the 5 over to the other side. So I would say, I'm going to set this equal to 5. And then, hey, this is quick, and boom. Half of 8 is 4. Then I'm going to say, what am I going to add over here? Let's add 16. Half of 2 is 1. So what am I going to add over here? 1 more. So if I add that all up, grand total, I would get 22. Well, 22 isn't a perfect square, but that's not important. The center of this circle would be at negative 4, 1. The radius would just be the square root of 22, which is a number. You could convert it to a decimal if you had to. So you could plot it or draw the circle if you had to. Okay, so once again, every lesson that I am doing is just to get you there. So you could now answer question 9 and 10. We've talked about this one, this one, this one. We've done them all. We only have one left. It's this guy right here. Now here's the thing with this. This guy is a hyperbola. And the reason I know it's a hyperbola is if I wanted to get x and y on the same side, I'd have to subtract that over. When you have a squared thing minus a squared thing, you have a hyperbola. So that's going to be video 8. That's my last little video to help you out. We've already covered all the other stuff. And once again, I've mentioned this to you. Stuff like graph the line through this with the slope of this, that's Algebra 1 stuff. I am not going through that stuff. If you need to Google it to refresh your memory, so be it. But I'm focusing just on the stuff that is new information. Okay, guys, we have one more video to find out how to do this question here. All right, and that one's a little bit funky, but it's totally doable. See you in the next round.